And here the second problem that I received a comment regarding to its solutions. And what we have here, we have a wire and carry the current 10 times the loop current. And since I have wire and loop, so the starting point, I have both formula for the magnetic field of the wire and the loop. And the second one, and we have the magnetic field for both of those lines or for both of those currents. And the key point here, they generate a magnetic field. That magnetic field will be zero at the center. So to get the zero at the center, so since we know the direction of the current in the wire, so we can identify the magnetic field if from this current. So right-hand rules, we can identify the magnetic field will be point to the page and including inside the loop, which this is my interesting area in this case. And since the magnetic field equals zero, in that case, the color, change the color. So to get the magnetic field from the loop or at the center equals zero, the magnetic field comes from the loop should be point out of the page. So that direction of magnetic field. They should be point out to generate another magnetic field. They have opposite directions of magnetic field comes from the wire. So here's the first one. The direction of the magnetic field will be point out of the page. Now I have the formula for the B wire. Will be mu0 times I wire. It's called IW, divide by 2 by, I will type D instead to the R with the same thing here is R. And B from the loop, that's the formula for mu0 times the current comes from the loop, will go through the loop, divide by 2R with the R, the radius. So I have two formulas. So to using directions and the magnitude of the magnetic field, so I can, so they have both of them. So the B wire will has a component just in X directions, positive X, and B loop will be negative X directions. And before we move on to define that D, from once I found the direction of the magnetic field comes from the loop, I can identify the direction of the current. It should be counterclockwise. Now, regarding from this formula here, I can type my, since they have X, one component in X directions, so I can find my B totals, positive and negative. Here is the B wire minus B loop. And the conditions here, they are vectors, they are equal 0, and they give me the total magnetic field equals 0. That means B totals equals 0. So from this one here, I can identify my B wire equal B loop. Keep in your mind, guys, this is the only case when I have total magnetic field equals 0, which in this problem here at the center. But I cannot claim that's work with any other point. Okay? So now that's what we have. Now I'm gonna replace just the formula for both wires. So here is the magnetic field to the wires, mu times I wire divided by 2 by D, and this one will be equal mu times I loop divided by 2I. So now the mu gonna be cancel mu, 2 gonna cancel So what I end up with the from here, so I can identify my D will be C. I think is gonna be I wire divided by I loop times the ratio between R and pi. So I have here is the I, 10I. So this ratio will be equal 10. So basically D will be 10 times R to pi ratio. I have here is the 10. I have here is the radius, already given the radius, 0.013 meters. Divide by pi, and this one will be 0.01 meters or equal 41 centimeter. That's the point, or that's the place where I want to put my loop at the 41 centimeters away from the wires to get the magnetic field at the center point equals 0. I'm done with that. Thank you so much, guys.